for robotics and hardware control. Always a fun topic. It's only a half-hour slot, so I imagine it's going to be quite fast. We'll see how we go. Our speaker this morning is Jonathan Foote. This is a half-hour session, which means we get 25 minutes of talking and 5 minutes of questions at the end. Please make Jonathan welcome.
Thank you. Hi, thanks for coming to my talk. There's no way I'm going to cover everything about robotics in half an hour, so I thought the best way I could do it is just present some of the stuff I've worked on and kind of give you my personal take on how this thing works. Okay, what's a robot? Well, this is my personal take. People may disagree, but a robot for me has to have three important things. It's got actuators, it's got motors to zip it around, or a robot arm. It has sensors, which tells it what it is or what's going on in the world, and it's got some kind of feedback, which tells it what to do based on the sensor input. Okay, so let me introduce you my first robot, and this is my friend Chassis. And Chassis is basically a mobile kegerator. He's got little motors on the base, and he drives around and he dispenses beer from a keg that's stored in his internal unit there. Chassis, by my definition, is not actually a very smart robot. First of all, there's no Python. Second of all, there's no real feedback. The way Chassis works is there's some jerk with a remote control, that's usually me being the jerk, driving Chassis around. So he kind of fails at being a robot by my definition. Okay, so let me show you something which doesn't look like a robot, but which is closer to my definition. Okay, Cho is a chocolate factory that's down on the Embarcadero in San Francisco. Anybody been there? Okay, if you're down there, if you're, the Exploratorium is opening up right next door, amazing chocolate, go down there and get a free taste. But they built a chocolate factory right there in this old warehouse on the Embarcadero. And this was founded by some of the people who started Wired, so they wanted some high technology in their chocolate factory. So I helped them with a system that basically you can control some of the things in the flavor lab from an iPhone system. And this is kind of how it works. On the right is a nice little iPhone app. It wasn't even an iPhone app, it was a specialized, basically, web server that formatted things nicely for the iPhone. We even got real-time video on it. Basically, we had very standard SQL, Apache web server. Python was the glue that let the web server talk to the equipment, and the equipment talk back to the web server and thus to the iPhone. So kind of the magic box here, this is an Ethernet to serial port here. Now if you want to do a drinking game in this talk, you can drink every time I say serial. I'm going to say that a lot. Okay, and right down here is a little feedback controller, and this is used to maintain a vat of chocolate at a constant temperature. It's a glorified thermostat. You put a thermocouple in, it senses the temperature, and then you give it a set point, and then it will turn on the heater or turn it off the heater, basically to keep the vat of chocolate at the right temperature. And you can set that set point over the serial thing from your iPhone, send something to the Apache web server, which talks to the Python, which sends the appropriate serial commands through this thing to this thing which does the feedback. Okay, what's this feedback thing that I'm talking about? Okay, don't worry, this will not be on the test. Okay, this looks kind of gnarly, but there's one inside basically every robot and possibly a lot. This is a little feedback loop. This is a classic PID, proportional integral derivative feedback loop. It looks gnarly, it's not actually that gnarly. Okay, here coming in on the left is you. This is the set point. Think of this as a thermostat. This is the temperature you want your house to be at. Okay, over here on the right is your plant. This is your process. This is the house you're living in, and it's got a thermometer which tells you what the temperature actually is. Okay, and this stuff is in your thermostat. You subtract the temperature you want it to be from the temperature it actually is. If it's too hot, you turn on the AC. If it's too cold, you turn on the heater, right? And then it just senses this again. Whoops, gotta go back there. It does this again and again and again. It's not very bright. It just sits there in this little loop saying, is it too hot? Yes, it is. Turn it on. Turn on the AC. Is it too cold? No, it isn't. Keep the heat on. Just like that. Not very bright. Okay, so this is where Python comes in the stack. This feedback loop you probably want to do on bare metal. It's very You want to do this as rapidly as you can. It doesn't take much computation. You probably don't want to have to go off and do garbage collection while you're in this loop, especially if you're doing something time critical like a moving robot arm or something. Okay, now where Python comes in is on the high level, at least on the systems that I've built, where you basically set the set point. You tell the robot arm where to go. You can do that from Python. And up here, this is either a brain or the cloud or whatever it is, because once you've got it in Python, Python has a built-in web server, then you can talk to it basically from anything. So basically the way to think about this, if you like the model view controller thing, that everything below the dotted line is your model, and then you can control it with commands from Python, and you can query it and maybe display the results in Python. And that's what I've done a lot. Okay, so some more robots. This is Swarm. This is a project I did with a bunch of friends almost 7 years ago. And if you're clever, you can buy these feedback controllers off the shelf. You can buy a robot arm which has this feedback controller built in. We weren't clever. We built all this stuff ourselves, and we had a lot of fun kind of over-engineering this. And there were 6 of these things, only 4 showed in this picture. We controlled them over serial, using a ZigBee wireless protocol, which was doing serial commands to each one of these things from a central brain. And the central brain was running Python. In our early development thing, we used WX-Python, which talks to a joystick natively. You plug in the joystick, and you can send commands to one of these things. Good stuff. Here's another thing. This was really fun. This is a little Maker Faire project I did, once again using WX-Python, which does really nice GUI development. I'll talk about that a little bit later. Basically use the joystick to control a bunch of these desk lamps I got from Amazon, throw some hobby servos on them, talk to them, once again using serial, which would send the right control signals to each of the hobby servos to control each of the joints on the desk lamp. Okay, so where's the feedback in this? Well, the secret is the feedback is built in these hobby servos, and these are really fun to use. They're really cheap. If you want to get started, you can drive these with an Arduino. Other actuators you might use are bigger motors, DC brushless motor drivers, variable frequency drivers, and the servo motors like this, and they're super fancy servos that are not hobby servos that you can use for some of the walking robots, the little things you've seen that play the soccer games, or I'll talk a little bit about a medical device which uses a fancy Swiss one. Okay, so that's the actuators. On the sensors, just things that I've used that you might want to use for robots. A simple switch, basically. If you've got a MakerBot and it's got a gantry and you want to know when it hits the end because you're driving with a stepper motor, you don't know where it is, you just put a limit switch on it, and that's something you want to query with some hardware. Position encoders, if you've got a robot arm, you want an arm that senses the angle. If you've got IR sensors to tell you how far away you are. A glorified version of that is a laser scanner, which basically has a rotating thing. Google uses that on their self-driving cars. You can put one of those on a Roomba and do something called simultaneously location and mapping, or SLAM. Okay, so time for another robot, and this is a big scary robot, and this was something I did with my friend Charlie, and Charlie has the magical gift. He convinces people to give him money to build giant things with flames on top, and I think that's a wonderful skill to have. I wish I had it. So anyway, this is an art piece we did for Coachella last year, and each one of those segments basically has a joint between the next one, and they all move, and each one is hydraulically actuated, and so basically there's 4 towers, each with 3 joints, so we made 12 hydraulic servo actuators, okay? And you can see the hydraulic thing on the top right. That'll lift 35,000 pounds, and it's like, and on the left is each one of these joints has a sensor to sense what angle it is, and down here is basically a little board which we did that does the feedback and basically turns each one of these joints into a servo motor. You can say, basically, go to this particular angle, and by God, it goes. Kind of amazing. Now, is there anything scarier than a 30-foot robot with hydraulically actuated with flames? And I will have to confess that there is. This is something I'm working on for a client. It's a surgical robot, okay? And basically what this is it's for keyhole surgery. It uses a water jet to remove tissue rather than cooking you with a laser or cutting you up with knives. Yes, it's running Python. This is this GUI is written in WX Python, but don't worry, we're using these expensive Swiss motor controllers to do the actual actuation and position control. And right there is a little serial port on that motor. Okay, so let's talk about Python and let's talk about serial, because lots of things I've talked about use serial. I'm really happy to see something with a serial port because it means, yeah, I can control it. And the secret to this is pySerial, which is a library. It works on pretty much every machine I've ever tried it on, and it generates, it takes over the COM port if you have physical COM ports. Those are serial ports. Nowadays, nobody has those anymore, but there are these USB serial controllers. They cost $15. You plug them in, and they just work. And so pySerial is kind of the Babelfish of hardware. It's great. You can talk to anything on it. So you just say import serial, and you open that particular serial port, and you're good to go. Okay, now serial may look gnarly, and there's a lot of different flavors of serial. I just want to give you some of this alphabet soup. So if you see this in the future, you can say, oh, that's serial. You won't freak out. There's this things called two-wire interface and I2C. Those are very common inside hardware things. There's probably a couple in your laptop. One is talking to the temperature sensor. One is turning the fan off and on. If you've ever wondered how your laptop knows what monitors plugs into, there's a little I2C serial line on your video connector, which is saying, hey, I have this resolution, I can do this thing. This is transparent, but it's there. So those have their own clock signal, but more common in the real world or outside of your little box are these things. It's basically called RS-232. This comes back from the dark ages. This is classic old school hardware back from the days they used teletypes. And it's still around, and it still works, and it's really robust. And if you ever want a demonstration of that, go to Maker Faire, where everybody is trying to talk to their stuff using Wi-Fi, and it doesn't work because there's a Tesla coil in the corner. But if you're talking to it with a hardwire RS-232, it just works. It's great. Okay, so here's some of the protocols which can run on some of these serial hardware layers. There's a custom one. When I do a custom one or I use other people's, quite often that's ASCII, which is really nice because you can open Minicom or Hyperterminal and you can type in a command and the thing will take it and you can read stuff back from it. Modbus is a very common industrial controller. They use it in factories. It's a little gnarly. It has a checksum at the end of every packet. This is good when you're controlling things that basically giant crushers that could crush you. You want to make sure that you're doing lots of error checking before you actually send the signal to turn it on. DMX is also a very common one for theater lighting. More and more often it's been used for LED displays. That's basically just a serial thing. You can do that. I've done that in pure Python, generating DMX. MIDI, musical instrument digital interface. You can get a little shield for your Arduino, which does that, and the CAN bus, which is automotive, and I won't go into that. Okay, so formatting serial data, I said ASCII is great. The way pySerial works is that you just open this thing like a file. This is a serial port, and you can just write to it, which sends whatever data you have down the pipe, and you can read from it. If someone's sending you data, you just read it, just like reading a file. It's great. Pro tip, be careful of some things are line-based things, and some things care whether you use a carriage return or a new line. I've wasted half a day on this on several occasions. Why doesn't this thing work? Oh, because I used the wrong line terminator. So there's only two. You can do every combination if you have to. Some things want binary data. Some things give you binary data. Some friends of mine who are not Python people, they say, oh, come on, Python, you can't do this. Of course you can do this. Byte array. Byte array is great. You just give it data in an ASCII representation here, and it'll just pack it in an array of bytes. And if you need more complicated stuff, if you need to deal with floating point numbers, there's struct.pack and struct.unpack. So just those are all built in, and I use those all the time. They're really fun. Okay, probably the gnarliest thing I've come across is dealing with asynchronous hardware. And this happens because you tell the robot arm to go to a certain place, and it takes a while to get there. And it takes a long time in computer time. So basically, you don't want to sit there and poll it. You could, but that would block everything else you need to do. So you need to handle the asynchronous stuff somehow, like let it go, do its thing, and report back when it's done. Now there's a number of ways to do this, and you guys probably know Python better than me. You can probably tell me ways I'm doing this wrong or better ways to do this. But let me just go through a couple of things that I've used and one that I haven't. Okay, so select, if you come from the Unix world, there's this thing called select. You can open several basically pipes, and you can wait on them and do things when the pipes report back to you. And this is great. However, I'm a little scared to run this on Windows because I don't know what's going to happen. Because that's basically mapping the Unix system call. There's threading. This is great. I use this all the time. I'll give you an example on the next slide. You just have a little thread, and all he does is he sits there and he pulls whatever thing you need to know where it is, and he can report back to you when something happens. There's pyDispatcher. I haven't used that. Anybody use that? I'm told it's the basis for the what's going on in Django or something. So apparently that's there and that works. I haven't used it. Something I have used a lot is WXPython. Anybody use WXPython? Yeah, it's magic, isn't it? And it's got all kinds of things, and it's got this WX timer thing that goes in the background. You can get a callback at any time, repeated callback that's great for polling things. It's got this thing called WX delayed result when you can say, hey, I've got a time-consuming process, go on, do it, get back to me when you're done. And those have all worked for me pretty well. Okay, so if you want to play with this stuff yourself, on GitHub, I've made a little thing. Anybody have Arduinos? You can get them at Radio Shack. They're what, 20 bucks these days? Okay, here's some Arduino code and a little bit of Python, and it's basically does everything asynchronous. So if you have a GUI or a web app and you want to talk to the hardware, say you can use this little class and maybe do some stuff on the Arduino. You want to see what temperature it is, put a temperature sensor on your Arduino. You want to put an automatic door lock, you can put that as an output on your Arduino. You can send stuff to the Arduino, and the Arduino can report back stuff to you all asynchronously. When it reports back, there's a polling thing that says, hey, is there data? If there is, then it gives you a callback. Otherwise, you can just use the class and just write to it like a file. Okay, getting towards the end of my talk, I just want to give you some goodies here. There's this thing called Open Sound Control. Anybody heard of that? It's really neat. And there's a Python module, at least 2 Python modules, pyOSC and Simple OSC or something like that. There are clients for iOS and Android, and this talks over UDP packets, so over wireless. So you can sit there with your Android or your iPhone, and you can even hook it up to the accelerometer on that and use that as an input to send data to your robot, or you can get status back from your robot and display it on the screen. That's really fun. A friend of mine made a robot out of a milk crate and an old laptop, an ancient laptop, and he uses this to control it with a little tablet. Basically uses like a tank drive. You can move these sliders, which controls the wheels and drives the thing around. 1 minute Python. If you're new to WX Python, if you've never used it, go check out 1 Minute Python. It's great. You can get a GUI up and running on Linux, on your Mac, on your Windows thing in literally a minute. It really is that easy. It's great. And there's also something which I haven't used called the Robotics operating system. I think that was mainly done at Willow Garage up in Menlo Park. And that has, I think, a lot of really neat modules, like I talked about the simultaneous location mapping. I haven't used it, but it looks like it's really powerful. And so this, getting towards the questions, just a couple more things. If you want to build some robots, there's this thing called First Robotics. Anybody heard of that? This was started by Dean Kamen. Right, it's the best thing ever. If you want to get your hands dirty with hardware, go help some high school students. They basically give high school students a big box of hardware in 6 weeks, and they say, build a robot to compete with other high schools. And it's a great way to get into volunteering, into building robots. I learned a lot, even though the kids were building the robots. Great fun. In the Bay Area, there's a Homebrew Robotics Association. This is kind of like the Homebrew Computer Club of the 70s, only it's robots. No matter where you are, there's probably a hackerspace around you, and they're probably doing robots. And this is pretty much the end of my talk, so thanks for coming.
Okay, thank you. We do have plenty of time for some questions. So if you have a question, please come up to the microphone, or I can come over this way if you need a microphone over here.
Yes. So more and more devices have an Ethernet port instead of a serial port. What do you do then?
I'm sorry, if what has an Ethernet port?
Any sort of hardware measurement devices, thermal controller, thermostats.
Okay, well, it depends what's on the other end. On Python, you can just open a socket. If you have Python on both ends, just open a socket and talk to them, or you can tunnel over HTTP. There's lots of ways, or you can use this OSC thing, which does UDP packets. So lots of ways of doing things over the internet.
One question from when actually building some hardware which can be controlled with Python. Have you any particular insights or some experiences when using servos or any infrared detection sensors that can be used as components for building the robotic?
Well, it depends on what you want your robot to do, basically. The little hobby servos are great, but they don't move, they won't move a 35-foot high robot. So it really depends. You got to match your motors to the kind of torque that you need to do. So.
Do you know of a library that runs on the embedded side, so like on the microcontroller end, that helps interface with the Python communications? Like basically a simple and easy way to implement a command set so you can talk to things and you don't have to implement your own interpreter on the hardware side or on the microcontroller side?
I don't. There's probably something around there, but I've basically been writing my own. And the thing with a microcontroller is you just keep things really simple. Like you don't use JSON. You just do as simple as possible, which makes it easy. That's my approach.
Yes, hi. Correct me if I'm wrong. Process automation is a huge industry, very expensive industry, right? And there, let's say if I want to control a process, there has to be programmable logical controllers, PLCs, HMIs, human-machine interfaces, all that. From your talk, I'm getting a sense that this can be done really, really cheap. Am I missing something? Because what I have seen is that very expensive pieces of equipment and human-machine interfaces cost a lot. Can all this be done as easily as you described, or am I missing something?
No, you're absolutely right. And you're saying that the process control, basically you can get these things from Siemens or something, which is a very expensive way of running your factory. You can do that all homebrew. There might be reasons why you might want to use the professional stuff.
What are those reasons? Can you tell why?
Well, reliability, complexity, if you have If you're running a $10 million factory and something goes out, you can call up the application engineer and they will help you solve your problems or something like that. You could do this, a lot of this stuff, without that whole infrastructure. A lot of that is kind of legacy, and a lot of people are making a lot of money on this.
Can I take this idea and go to Chevron or maybe some of the big companies, oil drilling companies, or those who deal with it, and tell them and convince them to invest in this open source stuff?
Well, you can certainly try. You can certainly try.
Good. Thank you.
Sure.
If anybody's feeling quite inspired by the idea of using Python to do hardware stuff, I recommend you, if you didn't catch David Beasley's talk yesterday, that you look it up in the videos, because it was about using Python and $300 machines to do making stuff. So that's pretty neat. I do have a question though.
Sure.
So everybody's got a Raspberry Pi now. Do you have any suggestions for where we can go with those devices specifically to start making robots?
Oh, absolutely. And if you saw the Swarm project, which are the spherical robots which roll around, we would have killed for Raspberry Pi there. Those are great because you can put a lot of the brains and a lot of the high-level stuff right on the robot itself and still do some low-level stuff because it gives you the access to some of the hardware registers. You can get pulse width modulation, you can get nicely timing controlled signals. So that's a great platform for robotics. I haven't done anything. I've got one sitting on my desk, just ready to be in the next thing. So, yes.
So that was actually half of my question. The other half was, do you have a microcontroller of choice if it's something other than an Arduino?
Well, I've used PICs and AVRs, and AVR is what you use in the Arduino. At this point, I like AVRs better. So I have basically my own custom board, which is a glorified Arduino. It's got space for a Zigbee and things like that. And I program it in C, not the Arduino, but it's basically the same microcontroller. That's what I like. It's Chevy versus Dodge, whatever you want, or Chevy versus Ford, right?
Okay, I think that's all the questions we've had. So, wait, yeah.
All right, quick one. With Python being the top of the stack and you've got PIDs and other stuff at the bottom, one thing that I've noticed is people often have a lot of trouble doing gain tuning on controllers. What's your feeling about using this high-level, low-level communication path to maybe put machine learning into the tuning of gains for different control systems?
Right. Yeah, well, you can actually do that. He's asking about tuning the gain. So when you have these feedback controllers, one of the factors in there is a gain, which is how much oomph you get when you're out of spec. So if you have too much gain, you tend to overshoot. If it's not enough gain, you creep up on it. So one of the things you want to do is get the gain to go as fast as you can, but no faster. And so one of the things I've done is actually use WX Python to put sliders. I have 3 sliders for the P and the D and the I, so you can tune it there in real time. There's actually a fair amount of academic work on auto-tuning PID controls and things like that, and that was something you could certainly do in Python. That'd be great for it. I actually haven't done it. On the very few things I do, just a slider was enough. But it's a kind of a big space of parameters you need to find. Actually, there's a story there. The wave thing, the giant flame thing, we were doing that at Coachella, and they put us right in front of the dubstep tent. So, and basically we had to make this thing work during sound check. So I had to do all this kind of tuning at a probably 108 dB sound pressure level. So it's like, oh boy. But anyway, that's why they pay me the big bucks, or not. Okay. So why don't I get off the stage and make room for the next speaker?
Yeah, thank you.
Okay, thank you.